Hi, I'm Joe Gurman. I'm a solar physicist in the heliophysics division at NASA's Goddard Space Flight Center. All of the 8 large planets in the solar system orbit the Sun in a plane that lies within a few degrees of the Earth's orbital plane, the so-called ecliptic. So when we observe the Sun with a coronagraph that blocks the much brighter light from the Sun itself so we can see the faint corona, the Sun's hot outermost atmosphere, we get occasional glimpses of planets. And in this remarkable series of images, we actually get to see several different planets, and also in the upper left of the image you can see the Pleiades, the star cluster. The images of the planets come out here looking as though they have horizontal streaks because they're so bright that they overwhelm the electronics in the detector that's taking this image. Soho's extreme ultraviolet telescope allows us to see a variety of solar activity, and some of the most intense activity we saw was in the fall of 2003, which was a bit of a surprise because it was a couple of years after the maximum of the 11-year solar activity cycle. It's a beautiful clip, and it shows what Soho's extreme ultraviolet telescope can do. So what we're seeing here is those same periods of activity in the fall of 2003, only this time from Soho's coronagraph. And you can see a sequence of events, so-called coronal mass ejections, launching off in all directions as the active region rotates across the solar surface. And you also see what looks like snow on the windshield of a car driving through a blizzard, and that's energetic particles accelerated by the solar activity hitting the detectors on the Soho spacecraft. Prominences are cooler gas that flows along magnetic fields in the much hotter solar corona. And in this image from 1999, you can see the eruption of a huge prominence from a fairly high latitude in the Sun, and that tells us that it's associated with new cycle magnetic fields and with the expulsion of twist in magnetic fields from the old solar cycle. Each of those approximately 11-year halves of the magnetic cycle displays its own cycle of first increasing and then decreasing magnetic activity. And that's reflected in the intensity of extreme ultraviolet emission from gas that's trapped in the magnetic field. So in this image you can see a series of snapshots taken one a year over a solar cycle